Hello, current, future EC551 viewers. My name is Yongning Ma, go by Yang most of the time. This is the demo presentation / demo for TrackForce. So what is TrackForce? This is one sentence I really compressed down and I'm pretty proud of it. It's a mouthful, but TrackForce is a reference utility that can be used either in motorsport or automotive development purposes, which is precise down to the milliseconds. So picture this, or put it in your own imagination. So most of you probably driven a car or been driven around in a car before, and if you look at the side of the road, sometimes those speed signs that checks your speed flashes at you, and 8 out of 10 times you're gonna realize, that speed is different from your vehicles, and that is actually very common. Vehicle either have their speedometer configured wrong, or some automaker, especially Toyota, they tend to have your vehicle speedometer report a higher speed than you're actually going. This is fine for daily driving, but it's a problem for those that are either requiring precise timing information, that's say on an automotive track or people trying to develop vehicles. So TrackForce is a vehicle that gathers accurate and fast speed reading data over a GPS module in addition to G-force acceleration reading, which I call them vehicle dynamics and vehicle speedometer. The vehicle dynamics is the horizontal acceleration G-force that is being pulled. This project does not take account into any vertical acceleration. And at the same time, TrackForce use one 7-segment display to show a rough direction on which you're pulling. And then after that, I just said we have vehicle speedometer. So the project is divided by 4 parts, how it's comprised. We have the sensors themselves, that is the GPS module and the IMU module. And we have the processing system on the FPGA. In this case, I'm using a Zibo Z720 that uses AMD Xilinx Zynq 7000 series adaptive SoC. So the processing system is actually the ARM cores that's on the same die as the FPGA. The processing system does the parsing of the sensor data. And the sensor data gets sent into programmable logic, which is then filtered and also sent back to the PS for future development. But in the end, it gets all outputted to the 7-segment display. And here's a rough diagram of how that would look like. The top here is the actual top level that I'm implementing Verilog. Well, everything else is the Xilinx IP that drives this project. Well, okay, so that's all the abstract stuff. Let's move on to the hardware. All right, so I'm going to explain the hardware component of TrackForce. In the vehicle, I will have the FPGA in this box for some extra protection, the peripheral board right over it, plus a power supply. But over here, we have the Zibo Z7 revision 20 or -20 evaluation board from Digilent. That is the core that has the Zynq 7000 series chip on it. And over here, we have the peripheral board. Directly attached to the FPGA are 3 7-segment displays. One is going to be used to show velocity in kilometers per hour. Another one, order not exact here. Another one is going to be used to show the combined G-force of X and Y axes from the IMU, which means it will not be a calibrated 0 when it's sitting still. And over here, okay, again, order not exact. And the third PMOD is used with 1 digit, using its bars to roughly show which direction the vehicle is leaning on. And over here on the peripheral board, the red module is the GPS module. Over here is the antenna that plugs in on the other side. The GPS module connects to pin 1 on the JA connector which is a UR transmit on the GPS and an RX on the Zevo. And over here is the IMU, 9 degrees of freedom. To make parsing easier, because it really output a long string of data, the Adreno RP2040 Nano is used to only forward the X and Y axis data reading to the FPGA, which is going to be on pin 2 on a J connector. And power and ground distribute to the entire board. Okay, so that's the entire hardware assembly. Alright, so up next, I'll be driving my vehicle and demonstrating track force. For the full duration, my hands are on the wheel, my attention is on the road, the camera is either mounted on my helmet or on the roof of my car. Please be a nice driver and obey all laws and regulations on the road. Okay, we're back. So I'll roughly go over how the top level works, where it's connected, and how the rolling window module is created. We go from up to down, follows the path of data. We have 3 LFSRs run the mill that's parameterizable with their output. That's to generate test data. It is finicky because we don't expect random test data that random on the modules. But anyway, moving on, they can be replaced with the actual data that's being read or being fed from the PS or no. Now we have 3 FIFOs for the velocity data, X acceleration, Y acceleration, respectively. In the current implementation, it is actually safe to assume that we'll never get invalid data from the PS, because if it doesn't get anything, we'll just write it 0. But FIFO is still here just for the sake of it, to make everything safe. We FIFO the data that comes in, and they get thrown into the rolling window immediately. The rolling window, let's see, it's right here. It's again a parameterizable module. We have an input data in. And we have a window that's all initialized to 0. And we have the window size, that's how many samples we want to keep track, and the difference tolerance that's set differently for GPS and IMU. Upon every time we read the valid data from the FIFO before it, we calculate the average of the window and see if the current data is too great from the difference, is beyond the threshold. If it is, we throw it out. Well, okay, we save it in the window, but we don't use it for the output. We replace it with something that's in the that's our average. And then, but if it's within tolerance, we just feed it straight out, and it goes into the window as usual, and that will change the average as it moves down the line. Now the data comes out of the rolling window. Oh, and by the way, all the modules are ready valid handshake. Technically not necessary for the rolling window output, because the 77 control right after it is combinational logic in nature. But anyway, there's a control module that has 4 separate instances, one to show direction, one to show G-force reading, which is exactly the same as velocity, but give it different names in case there are modification needed. And there's the animate module that just shows the animation on the 7-to-7 display, which will be shown when the device is in standby mode. But other than that, this is everything that's in the programmable logic.